Hello everyone. Today we're going to be starting to work with section 7.4. 7.4 starts our work with what's called trigonometric identities. Now, identities are formulas that allow us to take a complex trig equation and break it down into smaller parts or easier to work with pieces. This first section, 7.4, is a review of all the identities we've learned so far, and then some practice with manipulation of trig equations so that we can use those identities. As we move on to sections 7.5, 7.6, and 7.7, we will learn some additional formulas or relationships between the trigonometric functions and how to apply those at that time. So all four of these sections will be in quiz number 4, and let's get started. So like I said, an identity is a relationship between functions, and it allows us to take a complex trig function and break it down into smaller pieces. For those of you moving forward into calculus, this will become very important in calculus. Here we're going to learn how to do it, we're going to practice, and then we'll move on to something else. Okay, so let's review the identities that we have so far. The first set is called the reciprocal identities. So these are the direct relationships between one trig function and another. So for example, sine of theta is 1 over cosecant of theta, which means that cosecant of theta is 1 over sine of theta, where theta is an angle. Same thing is true of the relationship between cosine and secant. So cosine of theta is 1 over secant of theta, where secant of theta is 1 over cosine. And then tangent has a reciprocal relationship as well as a ratio relationship. So tangent of theta is 1 over cotangent of theta and can also be written as sine of theta over cosine of theta. Cotangent, 1 over tangent, can be written as cosine over sine. One of the other sets that we learned already this semester is Pythagorean identities. So remember, this is based on the Pythagorean theorem. And sine squared theta plus cosine squared theta is equal to 1. Now, if you divide all things through by cosine of theta, then you get 1 plus tangent squared theta is equal to secant squared theta. If you divide all things through by sine squared theta, you get 1 plus cotangent squared theta is equal to cosecant squared theta. So these are our 3 Pythagorean identities, but the one you have to know for sure is this first one, because you can make the other 2 by dividing through. The other last one that we've already learned this semester is our even-odd identities. So if you have sine of a negative angle, then it's negative sine of the angle. Cosine of a negative angle is cosine of that angle, and then all the rest of them are based on those. So tangent of negative theta is negative tangent of theta, and so on and so forth. So this section is going to include what's called verifying trig identities. So you're going to have an equation on one side, or an equation with trig identities on one side, and one on the other side of an equal sign. And our strategy here is we need to make one side of the equation look like the other. So we want to make sure that the 2 things are equal. Now there are some rules on the way through. The easiest idea is to try expressing in terms of a single trig function to simplify. We should only work on one side of the equation. So you pick a side and work on that side and try and make it into the other side. You cannot work on both sides of the equation unless you're working directly with an identity. These, when we're verifying, we cannot work on both sides of the equation. When you get up to calculus, you're only going to have one side of the equation. So this is practice for that. And you can't verify something if you add and subtract from both sides. It's typically best to choose the more complicated side because it's easier to make something less complex than it is to make something more complex. So we'll go through some and how to pick a side as we go along. All right. My strategy for how we're going to work these things is if we're verifying identities, I'm going to work under the identity on the verification part. any facts that I use, I'll put over on this side so that you know which facts they refer to. For purposes of our course, you will have to have all of these basic trig identities down. So you will not be able to use notes and whatnot on these basic trig identities. Some later on more complex ones I will provide, but these basic ones you will have to have down. All right, so let's verify this new identity. Now, if I'm looking at this one, I have a complex side and a non-complicated side. So I'm going to be working on this side to try and make it equal 1. Now, it says to try and express in terms of a single trig function. So typically, I try and express things in terms of sine and cosine. Those are the basis for everything. So if we express in terms of sine and cosine, then usually nice things happen. So secant is not a sine or cosine, but it has a relationship to 1. So secant of x is equal to 1 over cosine of x. So I'm going to substitute this identity, this relationship, into that side. All right, replacing secant of x with 1 over cosine of x, I get 1 over cosine of x times cosine of x is equal to 1. Now I can cancel those cosines, so 1 times 1 equals 1, and it's equal to 1. Check. So my goal at the end of the day is to make sure both sides of the equation are equal, and we're using the less complex side to make it equal to. All right, let's try another one. Okay, so I have cosine squared x minus sine squared x equals 1 minus 2 sine squared x. Now, as soon as I'm seeing squared trig functions, so anything squared like this, I'm thinking Pythagorean identities. So we do have a Pythagorean identity that has to do with sine and cosine. So sine squared, I'll use x's, plus cosine squared x is equal to 1. Now I have to decide how I want to use this identity. So if I'm looking at my equations that I need to verify, the right-hand side here has sine squared and a 1, but no cosines. The left-hand side has cosine and sine. Now I can't just switch out this for 1 because I have the wrong sign in here. This has plus in the identity, and on the left-hand side of my equation I have minus. But maybe we can try and trade out this cosine squared because the opposite side of the equation only has sine squared. So I've got an extra piece over here that I don't need. Now you can move things around on the identity side of things. So this side, when we're working over here, we can add and subtract from both sides of the equation. So I can subtract sine squared x over to the other side. So cosine squared x is equal to 1 minus sine squared x. And then I can take that and substitute. So you notice that this cosine x squared x and cosine squared x here. So I can take this cosine squared x out and replace it with what it's equal to, 1 minus sine squared x. And then we'll go from there and see what we can simplify. So 1 minus sine squared x minus sine squared x is equal to 1 minus 2 sine squared x. All right, if we combine like terms, I have negative sine squared and negative sine squared, which gives me negative 2 sine squared. We can add them just like variables. And my two sides of my equation are the same, so we're good to go. All right, moving on. I have tangent of x times cosine of x is equal to sine of x. So remember that strategy is to write everything in terms of sine and cosine. My left-hand side is the more complex side, so that's the side I'm working with. I have cosine already, so tangent of x is equal to sine of x over cosine of x. So I'm going to rewrite my tangent as sine over cosine. So sine of x over cosine of x times cosine of x is equal to sine of x. Canceling our cosines, I get sine of x is equal to sine of x, and that is true. All right, secant squared x minus 1 over secant squared x is equal to sine squared x. All right, remember that we have the Pythagorean identities. So Pythagorean identities is what I'm thinking about when I see squared terms. All right, so let's see what we have that has to do with secant squared. Now, if I forgot all but the first one, and I just have sine squared x plus cosine squared x equals 1, and I mention this because in a testing situation is the first time you're going to forget things that you already know. So if I'm looking for secant, then what I want is I want 1 over cosine somewhere. So remember, secant is 1 over cosine. So I'm dividing this through by cosine squared because I'm going to end up with 1 over cosine squared on the right. So cosine squared x on the bottom of everything. Simplifying, sine squared over cosine squared is tangent squared. And we have 1 and secant squared x. So I'm starting with secant squared x minus 1. So I'm going to bring the 1 over to the other side. Tangent squared x is equal to secant squared x minus 1. And let's switch that out and see if it helps. I'm going to take this and I'm going to replace this part with it. Now, I want you to note that when you're new at doing trig identities and trying to verify trig identities, you don't always go down the right path the first time. So if you trade something out and you're making a mess and jumbling things up, try again, do something different. This does take some practice, so as you go through, keep that in mind. Now, when you're working on your homework in my labs, they will give you choices where you have to verify the logic all the way through. So make sure that all the substitutions are appropriate. My suggestion is to write it out and see if you can do it on your own, and then see which one matches your logic as you go through. But you can take a look at the answers and determine which one is correct based on that as well. All right, so I'm switching out the top with tan squared x. And on the bottom, I have secant squared x, and we want it to equal sine squared x. All right, I've got tangent squared over secant squared, so I'm going to use that turning everything into sines and cosines. So remember that tangent, this is another note, squared x is sine squared x over cosine squared x, and that secant squared x is 1 over cosine squared x. All right, writing those two, that means on the left-hand side I have sine squared x over cosine squared x divided by 1 over cosine squared x, and it's equal to sine squared x. The right-hand side's just kind of tagging along for the ride. All right, fractions, dividing fractions, hold, flip, multiply. So sine squared x divided by cosine squared x times cosine squared x over 1 is equal to sine squared x. Cosines cancel, and we have success. Check. All right, number 5. Number 5 works with the same identities as number 4, except we're halfway there. So Tangent of x over secant of x is equal to sine of x. I'm going to use those reciprocal relationships and the ratio. So remember that tangent of x, we're not squared this time, is sine of x over cosine of x. And secant of x is 1 over cosine. All right, rewriting that. And then holding, flipping, multiplying. So sine of x over cosine of x times cosine of x over 1 is equal to sine of x, and we cancel, so we get sine of x equals sine of x. All right, number 6. I have cotangent x plus tangent of x is equal to secant of x times cosecant of x. Okay, so when you're trying to decide which side is the more complex side, it's always easier to make two things into one, like add them together, than it is to make one thing into two. So if I'm trying to decide which side to simplify, I'm going to work with this side because it's easier for me to put those two things together than it is for me to break the other side apart. All right, so let's strategy, sines and cosines. So there's no identity that deals with cotangent plus tangent. So I'm going to go with sines and cosines and see if we can make something work. So as far as our identities that we're using, cotangent of x is equal to cosine of x over sine of x, and tangent of x is equal to sine of x over cosine of x. All right, so cotangent, I have cosine of x over sine of x, tangent sine of x over cosine of x. And somewhere down the line, we want it to equal secant of x times cosecant of x. I'm going to put those in parentheses because easier to look at. Okay, so when you are adding fractions, remember that we have to create a common denominator. So if I am working with like 3/4 plus 2/3, for example, then I'm going to multiply the 3/4 by 3 over 3. And I'm going to multiply the 2/3 by 4 over 4. And we end up with 9 over 12 plus 8 over 12. And then we'll finish that off in a second. So same thing is true with trigonometric fractions. So I need to create a common denominator. So I'm going to multiply the first fraction by the denominator of the other, so cosine of x over cosine of x. And I'm going to multiply the second fraction by the denominator of the first, so sine of x over sine of x. Now notice I'm still only working with that left-hand side, so I haven't bled over into the right-hand side at all. Remember, you only get to work on one side of the equal sign. All right, multiplying cosine of x times cosine of x gives us cosine squared of x. And in the denominator, I have cosine of x times sine of x. Sine times sine gives me sine squared. And in the denominator, I'm going to write it in the same order. Remember that if you're multiplying 2 times 3, it's the same as 3 times 2, so you can switch the order in multiplication. All right, so cosine of x times sine of x, and we're equal to secant of x times cosecant of x. All right, when we add these together in regular fractions, we end up adding the tops, so 9 plus 8 gives us 17, and the bottoms become one single denominator. Same thing's true over here, so cosine of x, cosine squared of x plus sine squared of x all over cosine of x times sine of x. And we have secant of x and cosecant of x. All right, moving on. I know that cosine of x plus cosine squared x plus sine squared x is equal to 1 from the Pythagorean identity. So note cosine squared x plus sine squared x is equal to 1. So I'm going to replace this top of this fraction with 1, and I get 1 over cosine of x sine of x is equal to secant of x times cosecant of x. All right, remember also that cosine, 1 over cosine of x is equal to secant of x. And 1 over sine of x is equal to cosecant of x. All right, so technically if you're trying to turn this left-hand side into the right-hand side, you really should break it into two fractions first. So really this left-hand side is 1 over cosine of x times 1 over sine of x, because 1 times 1 gives me 1 for the top. It's hard to not skip that step because you can directly see how the other one works, but this really is what makes it a legitimate flip. So now we can flip those over and we get secant of x times cosecant of x is equal to secant of x times cosecant of x. And we have success. All right, that is the last one. Now, last example for today. If you have any questions, please let me know, and good luck on the homework for this section. Have a great day.